Hello friends, welcome to Intellify. Today our topic is scattering of light. This belongs to the chapter The Human Eye and the Colorful World, which is a subject of science, class 10th. Scattering of light. The interplay of light with objects around us give rise to several spectacular phenomena in nature. There are different spectacular phenomena that the nature has gifted to us. Like for example, we can say the blue color of the sky, the color of the water in deep sea, the red color of the sun at sunrise and sunset are some of the best examples that I can give. Now we'll see what is scattering of light. Scattering is the process of absorption and then re-emission of light. So here two things are happening. That is, the first one is absorption and the next one is re-emission of light energy. Now we'll see what is Tyndall effect. The Earth's atmosphere is a heterogeneous mixture of minute particles. Now when I say it's heterogeneous, that means the Earth's atmosphere consists of different mixtures of minute particles. Now if it was a homogeneous means, then the mixture would be of the same type. Since it's heterogeneous, that means it consists of different types of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust and molecules of air. So because of the different types of particles present in the atmosphere, we call it a heterogeneous. Now when a beam of light strikes such fine particles, the path of the beam becomes visible. So only when a beam of light strikes the small particles, the path of beam of light is visible to us. The light reaching us after being reflected diffusely by these particles. So only after it is being reflected by these particles it reaches us. The phenomenon of scattering of light by the colloidal particles give rise to Tyndall effect. So the phenomenon of scattering the beam of light by these colloidal particles, that is by these different types of particles, is what is known as Tyndall effect. Now this phenomenon is seen when a fine beam of sunlight enters a smoke-filled room. Now this effect can be seen in the same way when a fine beam of light enters a smoke-filled room. So thus we can say that scattering of light makes the particles visible. Another example I can give for Tyndall effect is when sunlight passes through a canopy of a dense forest. So that can be also said as a Tyndall effect. Tiny water droplets present in the atmosphere scatter lights. Now the color of the scattered light depends on the size of the scattering particles. So the scattering particles could be either big or either small. Maybe it could be of a combination of big and small particles present in the Earth atmosphere. Very fine particles, that is very small particles, scatter mainly blue light, while particles of larger size scatter light of longer wavelengths. That longer wavelength means like colors from red. If the size of the scattering particles is large enough, then the scattered light may even appear white. So if it is too big, then the light will appear to us as white. Next we are going to see why is the color of the clear sky blue. The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. So when we compare the particle size with the visible light, we can see that they are much smaller to the wavelength of visible light. Now these are more effective in scattering light of shorter wavelength than the one having with longer wavelength. So shorter wavelength would be colors like blue and light of longer wavelength would be colors like red and so on. Now the red light has a wavelength about 1.8 times greater than that of blue light. Now when the sunlight passes through the atmosphere, the fine particles in air or in atmosphere scatter the blue color, that is blue color is having shorter wavelength, more strongly than the red color. In another way, I can say that the light travels through the atmosphere and it gets scattered in different directions because of the air molecules present in its path or in its way. Now the blue or the violet light, because they are having shorter wavelength, they are scattered more as compared to the red light of the longer wavelength. So we can see the light reaching our eye directly from the sun is rich in red color, while the light reaching our eye from all the directions is scattered of the blue color. So this is how I can say that the color of the sky is blue. Imagine that if the earth had no atmosphere, there would not have been any scattering, and I think that statement is true because then the sky would have looked so dark. The sky appeared dark to passengers flying at very high altitude as scattering is not possible at such height. So remember, scattering is not possible in such higher altitudes. Now we'll see the red color of the sun at sunrise and sunset. At the time of sunrise and sunset, the light from sun has to travel the longest distance of atmosphere to reach the observer. So it's like the light has to travel a very long distance. Now the light traveling from sun loses blue light of shorter wavelength due to scattering. So when it reaches the observer's eye, the blue light would be scattered, while the red light of longer wavelength is scattered a little. So the blue light is almost absent in sunlight reaching the observer's eye, while it is rich in red color because we can say that white by minusing blue will give you red color. So when reaching the observer's eye, the only color left behind is the red color, which is having longer wavelength. Now we'll see an experiment to prove what I said just before. So in this experiment you can see there is a strong source which is represented by S, and then there is a converging lens, a transparent glass tank, a circular hole, and a second converging lens also. Now what we are going to do is we are going to place a strong source of white light at the focus of a converging lens. Now this lens provides a parallel beam of light. So that is what that lens is going to do. Now allow the light beam to pass through a transparent glass tank containing clear water. In the diagram you can see it is represented by capital T. Now allow the beam of light to pass through a circular hole C. I hope you are able to see C, made in a cardboard. Now that C is made up of cardboard. Now obtain a sharp image of the circular hole on the screen. Screen is represented by Mn using a second converging lens L2. Now next what we are going to do is we are going to dissolve about 200 gram of sodium thiosulfate in about 2 liter of clean water taken in the tank. So now the tank is having 2 liter of clean water and we are going to dissolve 200 gram of sodium thiosulfate in it. And after that we are adding about 1 to 2 ml of concentrated sulfuric acid to the water. So what happens is that we will find fine microscopic sulfur particles precipitating in about 2 to 3 minutes. So waiting for 2 to 3 minutes you will see that sulfur particles are precipitating in it. As the sulfur particles begin to form, we can observe the blue light from the 3 sides of the glass tank. So first color that is visible to us is the blue light that is coming from 3 sides of the tank. This is happening because scattering of shorter wavelength by minute colloidal sulfur particles. Now when we look at the fourth side of the glass tank facing the circular hole, we can see or we can observe that at first the colors would be like orange and red color, and then the color changes from bright crimson red color on the screen. So it's like first it was orange, then it showed red, then it turned to bright crimson red. Now with this activity or experiment we understood the scattering of light, and with this we can also understand why the sky is having the blue color as well as why there is reddish appearance in the sky when the sun is rising as well as when the sun is setting. Here we'll see that light from the sun near the horizon pass through thicker layers of air as well as larger distance in the Earth's atmosphere before reaching the observer's eye. So it's like the light from the sun has to cross 2 important things. The first one is the thicker layers of the air, and second thing is larger distance in the Earth's atmosphere. Now light from the sun would travel relatively shorter distance. So at afternoons or at noon, we can see that the sun appears white, a little of the blue and violet colors are scattered. So at afternoon, the sun appears white because blue and violet colors are scattered. Now near the horizon, most of the blue light and shorter wavelengths are scattered away by particles. So the light that reaches our eye is of longer wavelength, and this gives rise to the reddish appearance of the sun. Thank you.